All right. I hope you're ready for the next exciting notes segment. It is note 6.3, angle and perpendicular bisectors. Yeah. All right. This one really isn't too bad because we know what an angle bisector is and we know what a perpendicular bisector is. We're just going to start applying these concepts to triangles. So we're going to use perpendicular bisectors to find segment measures, and we're going to use angle bisectors to find measures and distance relationships. If you would like more information on this topic, please feel free to go to your textbook, pages 272 through 284. I'm sure you will all do that with excitement. All right, here we go. So, perpendicular bisector theorem. So if we read over here on the left, the perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if we look pictorially and to see what that says, basically we are coming in here and we're saying that, hey, we have a right angle. AB is perpendicular to PC, and we know that PA right here is perpendicular to PB. So what that means for us is that AC is going to be congruent to CB. It's going to have equal measures. So if we think about what this is really saying, no matter what point we pick, if I pick a point down here and I draw a line connecting these two segments, this segment here and this segment here are going to be congruent. I think I put 4 marks on that. So any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Then the converse basically says the same thing backwards. So if we have segment AC congruent to segment BC, that means you can come in and you can draw this perpendicular bisector, which is represented right here, or draw this line segment, and it is the perpendicular bisector. So basically what that would mean would be that AP or AB is perpendicular to PC, and that PA is equal to PB. So basically, if you have an isosceles triangle and you drop the altitude, you go through the vertex, you're going to form right angles. And when you do that, it's going to make these two segments congruent. Perpendicular bisector. Let's apply it. Example number 1. BD is a perpendicular bisector of segment EC. So when I see, and again, key vocabulary words, I've tried to train you since the beginning of the semester, perpendicular bisector. Come in on my picture, that basically means these are perpendicular and these are congruent. It says find x in the length of EC if angle BDC is 2x squared minus 38 and the two segments ED is 7y minus 5 and DC is 5y plus 7. So I'm going to mark that on my picture. ED is 7y minus 5 and DC is 5y plus 7. So I think I'll just tackle the segments first. Because this is a perpendicular bisect or two congruent segments, that will allow me to come in and say that 7y minus 5 equals 5y plus 7. If you want to do a little bit of quick algebra, probably easier for you to do this on your own versus copy what I do, so I'm not even going to talk. All right. So after you do your little bit of quick algebra, we get that y equals 6. It doesn't matter what equation you plug that in for. You can do 7 times 6 minus 5, or you can do 5 times 6 plus 7. Either way, we should get 42 minus 5 is 37. 37, so the length of ED is going to be 37 units. Oh, actually, it's EC. Sorry. Oops. EC. Wrong segment. Okay. So EC is going to be, nope, I did. It's, oh, EC. Interesting. Hey, Judy, pay attention. So ED is 37, but come up here and look at what they want in the problem. They don't want ED. What do they want? They want EC. So about made a common mistake that I see you guys make quite often. So let's fix that. So EC is going to be double that 37, which is going to be 74. All right, Whew, that was a mess. All right, so now let's talk about our angle. So angle BDC is 2x squared minus 38. So when I come look at BDC, the cool thing about BDC is I see this little symbol in here, which means right angle. And I know that all right angles equal 90 degrees. So I know that 90 is going to equal 2x squared minus 38. Many of you are looking at this thinking, oh my God, I'm going to have to factor. But here's the deal. You have a quadratic term, but you don't have another term with an x in it. So this is a quadratic binomial over here on the right, but because it only has one variable in it, you can just solve using the square root method. So what is the square root method? Well, let's get all the numbers on the same side and I will show you. All right, add 38 to both sides. And many of you don't skip steps on your algebra. It's lazy and you just make a lot of mistakes. A handful of you can do this and it's great, but anyway. Okay, so when I look, anytime you physically put a square root into a problem, you have to account for the positive and the negative case. So when I take the square root of both sides, and that's called the square root method, when you can isolate x squared or any term squared, you can take the square root of both sides. So x equals plus or minus 8. Because of the way our angle is set up and we have 2x squared minus 38, it doesn't matter if I plug a positive 8 or a negative 8 in, that answer is going to yield a positive answer. So in the end, no matter what, I will have a positive answer. So you always have to check your answers because sometimes they don't work in the context of a problem. We cannot have a negative angle measure, but I could have a negative value for x as long as when I substitute that back in, it gives me a positive angle. All right, so you guys take a minute. I want you to work through this problem, and when you are finished, rejoin me and let's check your answers. All right, so we know that WZ and TY, let's see, we know that TY and YZ are congruent. So over here, we know that TY and YZ are congruent, which also means the perpendicular bisector, any point on the perpendicular bisector is going to give you congruent segments, which in a sense makes the triangle isosceles. So we know TW and we know WZ. So in essence, I can take this problem and I can come over here and set 2x equal to 3x minus 5, which means negative x equals negative 5, and x is going to equal 5. So if I want TW is going to be 2 times 5, which is 10. WZ should be the same thing, but 3 times 5 is 15. 15 minus 5 is 10. If R is on the perpendicular bisector of TZ, so if R is on the perpendicular bisector, so now they just have us add some point R to this picture, then R is blank from T and Z. And what they're looking for is that word from the theorem and its converse. They're looking for that word equidistant. Equidistant, essentially forming another isosceles triangle. All right, that's perpendicular for you. Oh, nope, one more problem. So find the indicated measures if Jm equals 9x minus 18, and I know that these are hard to read on your worksheet, on your notes, and Mk equals 3x, and Jb is congruent to Bk. So Jb down here is congruent to Bk over here, which basically tells us these two segments are congruent. And it says, what is the relationship between segment MB and segment JK? So if you look, here's JK and here's MB. So if we look, they are perpendicular. And then what is the value of x? And find JM. So basically this is an isosceles triangle. So my two sides are going to be congruent. And if we do some algebra, I know that's your favorite, x is going to equal 3. And if I want the value of Jm, let's see if I can get this right this time, you're going to take 9 times 3 and you're going to subtract 18. So 27 minus 18 is going to be 9. All right, so now we're going to move on to angle bisectors. So angle bisector theorem basically says verbatim, if a point is on the bisector of an angle, so a point like point S right here is on the bisector of an angle, then the point is equidistant from the sides. So if this point is on the bisector, then they're saying it's equidistant from the sides, which means that PS is going to be equal to SR. So any point on an angle bisector, and you have to have these little marks showing that you have the angle bisector in order for these two little perpendicular segments to be the same. The converse just goes the other way around. If we have some point right here and we know that it's equidistant from the sides, then that tells us that we have an angle bisector. So it's going the other direction, and this time it would tell us that angle PQS is going to be equal to the measure of angle RQS. All right, angle bisector theorem. Okay, any point on the angle bisector is equidistant from the sides. And when we say equidistant, you have to look for the perpendicular mark because that is the actual distance to the side. If you start doing any angle other than a perpendicular, this theorem will not work. All right, so let's use our brains here. Example A, I'm looking at this picture and I notice that both of these are the same, 27 degrees for each of those angles. So that tells me I have an angle bisector, which basically means these two segments are going to be the same. Mainly, I have to have this perpendicular mark here. If I don't have that, then I can't make that assumption. Okay, so that's the angle bisector theorem. Example B is the converse of that theorem. So when I look, this segment here and this segment here are both 12. Because those perpendicular segments are the same, that tells me that the angles are congruent because the ray is an angle bisector. So again, some quick algebra. If I move my 3x over, I'm going to get x. I'm going to move my 6 over in the same step because I don't have enough room. And so in this particular case, x equals 11. All right, so looking at this particular picture, I am going to read the problem according to the diagram. How far is L from ray HK and from ray HF? So if you are looking at your picture and you have ray HK and you have ray HF, I can look right here and I'm 27 units here, which means that I am going to be 27 units here as well. So that means that they are 27 units from from point L. Says, how is ray HL related to angle KHF? So here's ray HL, and how is it related to this big angle right here? Well, because both of those little segments are perpendicular and they're congruent, that means that HL is an angle bisector. So ray HL is an angle bisector because KL is congruent to FL. And that technically isn't enough. You have to have that we have perpendicular lines. So LK is perpendicular to KH, and LF is also perpendicular, but it's perpendicular to segment FH. So you have to have those right angles along with the congruent segments, or the segment angle bisector theorem does not hold true. All right, last but not least, they want us to find the measure of KHL and FHL. So because I know that I have an angle bisector, I know that I'm going to set these two angles congruent. And now it's your favorite thing, algebra. Good thing you're good at it. So I move my 4y over, 2y equals 18, y equals 9, and that's it for this problem. All right, perpendicular bisectors and angle bisectors. It's all about relationships. So remember that when you do your homework and set your problems up, do some good algebra and make sure you answer the question. Oh, like I did not on part C, because I got y is 9, and now that I look at this, fatal mistake, forgot to plug it back in. So 6 times y equals 6 times 9, so that angle measure is actually 54 degrees. Whew, good thing I caught my own mistake. All right, y'all have a wonderful afternoon, evening, middle of the night, whenever it is that you are viewing this for your fun enjoyment, and I will see you in class tomorrow. Bye-bye.